So let's go to that analysis node, and I'm going to right click on it. And when I do, it brings up some options. I want the one that says add solution setup. I'll just leave that default name, that's fine. Maximum number of passes, just in case we're going to bring it up to, let's say, 25. I'll try to explain that later on in a subsequent session. And percent error, something else I have to explain, and I'm not going to go through it at the moment. I'm going to change it from 1% to 0.1. And everything else I believe is going to be fine. And I'm going to say OK. And let's see. By the way, I have not been saving my project like I asked you to do. Whenever you see an asterisk on your project here, or the designs, it tells me that there's things that have changed since the last save. And in order to preserve them, I'm going to go ahead and save. And then that asterisk goes away. So if I expand this node, I can see underneath analysis, apparently I can have multiple setups. And I'm just going to go with the one setup for now. Let's go to the simulation ribbon. When I do that, I have a big green check mark that says validate. Watch what happens when I hit the button. It goes through a number of things that have been defined in our workflow, all the way through the 3D model, the boundary excitations. The fact that I get all green check marks tells me that it should be ready to go for a solution. So there's nothing that I forgot. If I didn't have a valid setup, I should be seeing warnings here. It's always a good habit to go ahead and validate before you run. A number of ways to analyze. Right now, if I hit the Analyze All button, it's safe because I only have one setup defined. Sometimes we don't want to hit Analyze All because there are other things that we maybe forgot that we hit set. For now, I'll just go ahead and hit Analyze All. I think it's going to be okay. And when this happens, notice in the bottom right, I'm going through a simulation right now. So it's doing something called passes. I can see it's flashing very quickly. I'll explain what's happening here later on. Right now, I just want to try to get to a result. So we're on adaptive pass 7, adaptive pass 8. The performance of your machine could be different depending on what type of hardware you have. I'm running this right now on a Dell Precision laptop that probably has about 16 cores available to it. So it's a pretty good technical laptop. And it looks like my solution is complete. If I go into the message manager over here, I can see a number of things. This is exactly what I want to see. I want to see there's some verifications that took place, and it tells me that there was a normal completion of the simulation on the server. So it tells me that I have a result. So what I want to do now is, if we can remember the problem, I'll go ahead and bring over this example that we did before, just in the previous video. Remember, we calculated the electric field at 100 millimeters. And here's the value we got. So I want to do the same thing right now. So I solved for the electric field in an area of much more than 100 millimeter radius. So what I'm going to do is set up a point. I'm going to create. Let's do it this way. I'm going to go back to draw, and right here, this object here is draw a point. And what that's going to do is give me kind of an artificial object. That's going to be my observation point. So if I want to create a point and I want to place it at a distance that's 100 millimeters away. As long as I do that, it should give me a similar calculation to compare to our analytical. Or I should say it should give me a similar reference. So when I hit that button, I can look over here in the bottom left. It's asking me to enter the point position. Well, if I zoom in, I have to make a decision here. I'm in the XY, it looks like I'm drawing in the XY plane like we did before. So as I move this around, you can see that grid is aligned with the XY plane. I'm not going to worry about the direction. I just need to, we're only focused on the magnitude at the moment. So as long as I choose somewhere in the XY plane a distance of 100 millimeters away, then I'll be, that's exactly what I want to compare. So I can look at the measured data on the left-hand side right now, and it's telling me I've got a distance of, my X distance is negative 100 millimeters. I don't care about the direction and the sign right now. That's a good spot. So let me drop it right there as soon as it says 100 millimeters. And notice that I've got some new things that popped up over here. Underneath points, I've got this thing called 0.1. I can see it when I highlight it. It's not a geometry object. Instead, it's just used so I can reference it, if that makes any sense. And If you placed it in the wrong area and you want to change it, look how easy it is to come and make a modification. I can literally choose the object, and down here in position, I can type in any number that I want right now. So since I got it right the first time, I'm going to leave it. I'll click out of the dead space, and then now I have an object that I can calculate a result on. So I'm going to save this again, and I'm going to go right to results. When I go to results, I can do it this way. I can either right click on this, or I can go to the results tab, or I should say ribbon as well. Sometimes I like to operate from the ribbon when I look at results because some of the other options are a little bit more obvious. So I'm going to choose field reports, and I'm going to choose this thing that says data table. And when I do that, I get a window that popped up on my second monitor. And a couple different things here. I'm going to go over this very quickly for now. We'll come back to it later on. I've got a context section, and I've got this other section with trace, families, and family display. There's not going to be a lot to talk about in this section for now because this is a fairly straightforward thing that we're trying to do. But what's important is that my solution has to exist. It looks like we have a good solution. We'll find out in a minute. It says setup one, something called last adaptive. That's what I want to see. For my geometry, there's the point 1. So I'm going to choose the point 1. Now that I chose point 1, it's giving me some options in the category, quantity, and function here. And it's just defaulting to either calculator expressions, or I can see it's defaulting to a voltage here, and then some of these other functions it hasn't selected. I want to choose mag_E. That's the magnitude of the electric field. That's the exact thing that we calculated in the analytical part. And I believe I don't need anything for the function here because I just, yeah, I think that's good. With that, if I have it, if you have the same look that I have here, you should be in good shape. You can hit the new report button, and when you do, you can see something happen in the background. I'm going to close this window, and it looks like I have a value here. So let's, with the way that we set it up, it's not in scientific notation. We'll talk about that later, but if I can just count the zeros, if I can count the decimal places, it looks like we might be in the ballpark. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the value is telling me mag_E in volts per meter for this thing called last adaptive pass that I'll explain later. Looks like it's at 9.4 times 10 to the 11 volts per meter. And if I bring up this as a reminder of what we calculated, that's really close to 9 if we round it up, times 10 to the 11 volts per meter. So they're certainly not identical, and there's a good reason for that. And that's part of what we want to talk about in subsequent videos and tutorials about how to improve the accuracy. So this is a start. I would say we have to make some refinements on this to see if we can get this to agree better. And that will educate you a little bit more on what maybe some of the common practices and maybe habits would be when you build a computational model to verify it with your analytical estimate of what it should look like. And we'll do that in the next session.